Digital biology is thinking of the information of life the way that we think about information on a computer. So computers store information as zeros and ones. On Earth, life stores information as DNA. So as the building blocks A, C, T, and G, which are short for some chemical names that we use. So that's a really useful mental model because if you can think about life storing information as A, C, T, and G, then essentially anything that we can do with computer code, we can also do with DNA code or other types of biological code. So, if we move big pieces of DNA code around, that's called genetic engineering. We've known how to do that since the 1970s. If we write DNA code from scratch, that's synthetic biology. We're going to talk a bit about that today. And then, of course, if you go in and debug the source code of life one letter at a time, that's called gene editing. And there's all kinds of great technologies like CRISPR and base editing that empower you to do that. So that's the big mental model. And I mentioned synthetic biology is one of the areas that we can use that mental model as beginners to start accessing. So what's synthetic biology? Synthetic biology is when we combine biology, engineering, and computer science in order to design and construct and modify biological systems for specific purposes, contexts, and applications. So essentially the goal is to take the biological systems that we already have, thanks to about 4 billion years of evolution on this planet, and then use the tools that we're developing today in order to either have better performance or even have entirely new functions that, to our knowledge, nature hasn't used here on Earth.